Next topic, let's look at how to graph lines given a point and a slope. Draw a graph of the line contains the point 3, 2 and has a slope of, let's look at A first, 3/4. So given the slope 3/4 by its definition is the same as telling us rise over run equals 3/4, right? In other words, every 3 units rise, 4 units run. All right, so based on this and a given point, and then we can identify additional points on the line, and then we can graph the line as well. Okay, so now let's do the graph. Okay, set up rectangular coordinate system, x-axis, y-axis, the origin 0, 0. All right, let's put a scale now. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the negative direction, -1, -2, and then vertical direction 1, 2, 3, 4, 5, 6. And then -1, -2. All right, let's plot the point 3, 2 first. Okay, from the origin 0, 0, we need to move to the right-hand side 3 units and then going over up 2 units. So this is a point 3, 2. And then based on given slope 3, 4, so that means every 3 units up, right? Every 3 units up, and then 4 units go over to the right. 4 units run. 1, 2, 3, 4. All right. So what is the coordinates of this? You can rate from the rectangular coordinate system, that's 7, 5, right? We can calculate it as well. So rise is a 3. So rise, that's a y coordinate. 2 plus 3, that's how we got a 5. And then run is a 4. So that's adding to the x coordinates, right? 3 plus 4, that's how we got a 7. And then we use straight line, connect these 2 points. This is the line containing the point 3, 2 and with slope 3/4. Okay? So that's how we do this. Now let's look at the B. B is a little different than A. The concept is the same. The only difference is now we need to deal with the negative sign. Okay? So negative sign, you can go with numerator or go with denominator. Okay, so if you consider that's -4/5, that means rise is -4, run is +5. Okay, or you can consider +4 over -5. So that means rise is +4, run is -5. Okay, so it's, really up to you. That refers to 2 different points, but they're on the same line, okay, in different directions. All right, so we can still use the same graph, okay, on the left-hand side, so I don't, redraw the rectangular coordinate system. So still from the point 3, 2. Now, if we consider the rise is -4 units, run is +5. Okay, let's try that. 1, 2, 3, 4. Goes down 4 units, and then +5 as a run. So move to the right-hand side 5 units. 1, 2, 3, 4, 5. Right? So what is the point here? This is 8, -2. Right? 8, -2. And then we connect these 2 points, we can form the line. Okay, what if we consider the rise is +4, run is -5? Okay, let's see. Rise +4, 1, 2, 3, 4. We got here. And then run -5, 1, 2, 3, 4, 5. Okay, this point coordinates is -2, +8, +7, sorry. 6 or so, let me see. 2, and then goes up 4, right? That's a 6. -2, +6 should be. So you can see this, actually this 3 points, they are on the same line. Okay, my hand graph is not that accurate. Let's look at the book accurate graph. The A from 3, 2, right? Go up 3, go over 4. That's how we got a 7, 5. And then connect the 2 points, form the line. The B from 3, 2, right? Rises, if it's a -4, 1, 2, 3, 4. And then run is +5, 1, 2, 3, 4, 5. That's how we got here, 8, -2, right? That's in this direction. But if you consider the rise is +4, and then 1, 2, 3, 4, got here, and then the run -5, 1, 2, 3, 4, 5. That's how we got these points. So you can see these 3 points exactly fall on the same line. So in other words, you can use 3, 2 and then A -2 to determine the line, or you can use 3, 2, -2, 6 to determine the line. It doesn't matter, right? The negative sign goes with the rise or goes with the run. It really doesn't matter. You determine the same line. So the next, let's see, how can we find the equation of a vertical line? Graph the equation x equals 3. So now we know 2 points we can determine the line, right? And then we can use the third point to verify whether the line we graphed is accurate or not. So now if we want to graph the equation x equals 3, we can form a data table. So this equation only contains variable x, right? Doesn't have variable y. So that means what? That means y can be any number. So as long as x equals 3, and then y, you can choose any number, maybe 1, maybe 0, maybe 2, okay, any number. And then we can graph those lines, graph those points, and see what kind of line we can get. Okay, so create a rectangular coordinate system, and then we put a scale 1, 2, 3, 4, 1, 2, 3. So 3, 0, that's the point right here. 3, 1, that's the point right here. 3, 2 is the point right here. We can get many other points, okay? But if we connect these 3 points, you can see that forms a vertical line, right? Because all the points, they have exactly the same x coordinates. Y coordinates is different, and it doesn't matter, right? So that's actually is a theorem, okay? We talk about vertical line is a special type of line. So its equation, we consider that as a theorem. This is the book. Do the graph, use more points than what I did earlier. So equation of a vertical line can be given in this kind of form. X equals a constant. Okay, A is any constant. Actually, A is the x-intercept. So this is the theorem. Okay, next time, if asked you to write a vertical line equation, and then you can, if you can identify x-intercept, you can write a line equation x equals A. And then if you see equation like that, x equals a constant, and then you should know right away this equation represents a vertical line. Next, let's see how to use point slope form of a line. Okay, how to use point slope form to identify a line equation and how to identify horizontal line. So earlier we graphed, if we know a point, we know the slope, and then we can identify additional point on the line so we can draw the line, right? So same reason, we can find the line equation as well. So how can we find the line equation? Okay, let's see if we know one of the points, right, x, y on the line, and then based on the slope, we can find additional points, which is x1, y1 on the line. And then how we find the additional point is based on the slope, right? Rise over run. And then what is the rise? The two y coordinates find a difference, right? So that's y minus y1. And then what is the run? The difference of two x coordinates, x minus x1. So slope can be represented as y minus y1 divided by x minus x1, right? Here x1, y1 is a given point. So in this linear equation, if we both sides, okay, multiply by x minus x1, okay, we try to eliminate denominator x minus x1, and then what we have, this cancel out. So we have y minus y1, right, equals m times x minus x1, right? So actually this is the theorem, point slope form of a line equation. If we know slope of the line, and then we know this line passing through a given point, x1, y1, and then we can use point slope form of a line equation to identify the line. So let's look at the example, how to use point slope form, identify a line. It says the equation of a line with slope 4, okay, so m equals 4, contains the point 1, 2, okay, so given point 1, 2, so this is the x1, y1, and asks you to find the line equation. Okay, so based on the theorem, we write a point slope form because we know the slope, we know a point. Y minus y1 equals m times x minus x1, right? So all you need to do is plug in the slope, right? We know that, and plug in x1, y1. That's given by the problem, okay? So that's y minus 2, right, equals 4 times x minus 1. And then solving this linear equation, or rewrite this linear equation. So let's simplify. Y minus 2 equals 4x minus 4, right? Eliminate parentheses. And then both side equation add a 2, so y equals 4x minus 2. So that is the line equation we identified. Okay, so let's quickly review this process one more time. If we know the slope of the line, we know a given point, okay, this line passing through one of the point, and then we can use the point slope form to identify line equation. Okay, this is the point slope form. Just plug in the slope, plug in the given point. And then of course we can graph it as well. Okay, so earlier this is a 1, 2, right? We can plot the points 1, 2, right? From origin right 1 up 2. And then the slope is a 4. So that means every 4 units right, 1 units run. So we can identify this point with coordinates 2, 6. And then we connect the 2 points, form the line. How to find the equation of a horizontal line? Very similar as how we find the equation of a vertical line. Very similar. it asks us find the equation of horizontal line contain the points 3, 2. So we know horizontal line, the slope equal to 0, right? From the previous knowledge, we already know horizontal line slope must equal to 0, and any line with slope 0 must be horizontal lines. And then we plug in the point slope form. Y minus y1 equals m times x minus x1. And then we know the point, this is x1, y1. So we plug it in, right? Y minus y1 is 2 equals m, we know slope is 0, x minus x1 equals 3. So 0 multiply any number is still 0. So we can simplify y minus 2 equals 0 and then add both sides of the equation by positive 2. So we got a line equation y equals 2. Okay, so horizontal line equation is always y equals a constant, and this constant actually is the y-intercept. Okay, this is actually a theorem. That's how the graph look like. Okay, horizontal line passing through the point 3, 2. Okay, the line equation is y equals 2. Right? So horizontal line equation, you can memorize this as a theorem. Y equals a constant. This constant is the y-intercept. So let's recall, what about the line equation of a vertical line? Is what? X equals a constant, right? Remember? X equals a constant, that's the vertical line. And then y equals a constant, that's the horizontal line. Okay, here A is the x-intercept. In this line equation, B is the y-intercept. Okay, you try to memorize these two special type of line equation together. Okay, so you can distinguish horizontal line, because all the points on the line have the same y coordinates. Okay, that's why y equals a constant. For the vertical line, all the points on this line have the same x coordinates. Okay, that's why the line equation is x equals a constant. Okay, just find a way to memorize this.